Good morning and welcome to a special episode of The Angry Astronaut. Today we are joined by Dr. Gilbert Levin. This man has a very extensive background and has accomplished quite a bit in his life. In 1944, he was in the U.S. Maritime Service, serving on ships in the North Atlantic. Being a history major myself, I know that that was a dangerous place to be because of U-boats and those sorts of things. So thank you for your service, sir. And on top of that, he has accomplished quite a number of other things, such as working on the Mariner program in the early 1970s. In 2007, he was appointed adjunct professor in the Beyond Center of the College of Liberal Arts and Sciences of Arizona State University. And in 2011, Dr. Levin was made honorary professor at the Buckingham Center for Astrobiology of Buckingham University in the United Kingdom. His inventions include low-calorie sweeteners, therapeutic drugs, etc. But probably what he is the most familiar with, or rather what he is the most famous for, is his labeled release life detection experiment, which was on the Viking Lander in 1976, and to this date is the only life detection equipment that's ever been included on a Viking Lander or rover since, unless I'm mistaken. Welcome, Dr. Levin.
Thank you very much. Good to hear from you.
Thank you. So, my listeners are familiar with the basics of your experiments, but if you could just give us a little bit more detail on what what you were sending out to do, rather, in 1976, and what the results were.
Okay, let me try and describe the experiment very simply. It is not such a bold new experiment. It's just like most experiments, it's on the shoulders of other people. There is a test that has been used for more than 100 years by municipalities around the world to test the purity of their drinking water for contamination with microorganisms. It's very simple. They take a sample of the water to test, put it into a test tube of nutrients, and incubate it for 1 to 3 days. If during that time they see bubbles appear in the test tubes, that means that there are microorganisms present that are eating the nutrient and putting out bubbles, generally carbon dioxide. So I took that experiment and enhanced it a little bit by making it quicker and more sensitive by using carbon-14, which is radioactive and easily detected in the nutrients. I tagged the nutrients with carbon-14. And in addition, I added several other nutrients because I didn't know what Mars bugs, if there were any, might like. I used nutrients that were discovered in the Miller-Urey experiments that formed out of the primitive Earth atmosphere. So I felt if Mars had a similar origin to Earth, those were pretty good nutrients to use. So what we did was take the nutrient, 7 substances actually, and put them in the mission to Mars. When the spacecraft landed, it picked up a sample of the soil with that long arm that I'm sure everybody saw, and put samples in individual tubes where a drop of the radioactive nutrient was put on it. If there were microorganisms present, we should get radioactive gas out. And in both experiments, two Viking landers, 4,000 miles apart, that happened. Now, we were not content with the evidence that the municipalities take, just a positive response. We felt we needed controls as well. In other words, control experiments to assure that the positives were correct. So NASA suggested the controls to us to take a duplicate sample of any positive sample and heat it to 160 degrees, which they felt would kill any microorganisms, but not harm any oxidant chemicals that might have caused a false positive. Well, when we did that, the results were negative. So now we had the proof that we had wanted, that NASA said it would accept as evidence for life on Mars.
I see. And so also, I believe, Dr. Levin, you also heated it to a lesser degree. Is that correct?
Yes, we went on and did ad hoc experiments, and we found that this microorganism was sensitive to 50 degrees centigrade, and that even when stored in the box in which it was stored after collection for 2 months, there was no response. They all died, or whatever was active ceased being active. That makes it extremely difficult to explain by chemical.
Yes, that it's. I've always found it to be extremely difficult as well. So, Dr. Levin, I have also informed my listeners in the past that that no organic molecules were detected on that particular mission. However, since then, the Curiosity rover has detected organic molecules simply because I assume because the instruments were more sensitive. So the question I have for you, Dr. Levin, is since your experiments produced these results, and since the lack of organic molecules was the only justification that NASA presented at the time, to say that that life was not conclusively detected, why do you think NASA is taking the position that they are now?
That's a very hard question. After all, it's been, what, 43, 44 years since they sent Viking to Mars, and they've never sent another life detection experiment since. So I've thought, and I've talked with people about what could possibly be the reason. I mean, any scientific experiment that's positive deserves to be repeated, especially such an important experiment. But they didn't repeat it. They actually, for some 40 years, they forbade any mission carrying a life detection experiment. They now say they permit it, but they haven't done it yet. And even the new lander, I think it's Perseverance, on its way to Mars now does not have a life detection experiment. It's incredible. The only reason I've been able to put any faith in is that NASA wants to send men to Mars as soon as possible. If they acknowledge there are microorganisms on Mars, it could be these might be pathogenic, and the public would not like the idea of sending astronauts to a planet where they might get a dangerous disease and even might bring it home when hopefully they come home. So that's all I can think of. I know for certain NASA knows there are microorganisms on Mars. The evidence is absolutely overwhelming. Remember when Carl Sagan said that extraordinary claims require extraordinary evidence. Well, since then, the claims have become ordinary for many reasons. And the evidence has become not extraordinary, but overwhelming. So that it's very hard to imagine that there could be a sterile Mars.
Well, you're very much preaching to the choir here. So, in any event, a couple other questions. The recent discovery of both seasonal methane and oxygen in the atmosphere. Is this further indication of organic life? There are, for example, perchlorate devouring organisms on Earth that produce, I'm sure you probably know, that produce oxygen as a byproduct. Could it be that the presence of these gases is further proof of Martian life?
I think it's very strong evidence, especially since it's cyclical, just like the methane is cyclical and in isolated spots. It's very hard to imagine anything other than microorganisms.
Yeah, it does get overwhelming. So yes, your explanation does seem to be pretty compelling, or rather that because NASA wants to send people, that to acknowledge the presence of microorganisms, potentially dangerous ones, could present a threat to those astronauts. Now, I'm going to ask another question because the vast majority of my listeners are massive fans of SpaceX, the vast majority of them. And as you probably know, Elon Musk has some very, very ambitious goals of bringing humans to Mars as well. Now, of course, this is kind of a sort of a lesser of two evils sort of scenario. Before I ask this question, then let me ask one other thing. Since the Viking landers detected the presence of microorganisms at both locations, it suggests a rich and possibly diverse ecosystem. I mean, if they're that prevalent, do you think that might be the case?
I do think so. As a matter of fact, I think, as I've indicated and you've seen in my writings, that rocks carrying microorganisms have traveled back and forth from Mars to Earth and vice versa for millions of years. So I think that Earth and Mars actually consist of one biosphere, and that the microorganisms are probably very similar, but they might be different enough so that Martian microorganisms that evolved under its environmental conditions and mutated, therefore, might be dangerous to terrestrial life.
I understand. Are you an advocate then of transpermeation, that particular concept of life having traveled back and forth between the two planets rather than having evolved independently?
Well, I don't know which is true, and the experiment I wanted to send back to Mars would have determined possibly whether we're talking about one or two genesises, because I was going to send back a chiral label release experiment. On Earth, the life here uses only left-handed amino acids. So if we found the same thing on Mars, that would indicate a close relationship. But if we found that Mars microorganisms metabolized right-handed amino acids, that would mean an independent genesis. That would be a startling finding and would certainly indicate that there are microorganisms being born all over the cosmos.
Yes, I tend to agree, and really, it almost seems that NASA has gone so far as I'm sure you probably know to make statements that they would be rather surprised to not find life on places like Europa and that sort of thing, and therefore the Europa Clipper mission, which seems to make sense. What I'm curious about is why not a Europa Clipper mission for Mars? Or does it go back to the whole thing of, that might keep us from sending people?
Well, it might, but I kind of think it's amusing that NASA is seriously considering sending missions to the outer moons, thinking that it's likely that there's life there, but not on Mars, when all the conditions on Mars are favorable, and we really know nothing about the conditions on the moons.
Yes, yeah, that's it does seem a trifle absurd. To get back to my original question, given that you have a diverse ecosystem, and this is kind of a lengthy question, bear with me. And given the fact that the Apollo astronauts took the same risk, would it be, potentially safer for the human population on Earth if we had trained exobiologists going to Mars and studying the varieties of microorganisms that might exist there rather than robots, which are by nature limited to a few areas rather than many areas?
What do you mean, a few areas?
Well, in terms of, like, for example, they couldn't sample an area of the Valles Marineris, or it would be difficult for them to, find shadowy areas there. If there is a variety of life on Mars, do you think that humans might have a better chance of finding different varieties of life on Mars than a probe, or do you think that probes can accomplish it all?
You mean geographically? That's the advantage of humans. They can roam around.
Yes, they can go to different regions of the planet that robots cannot.
I guess that is so, but I think robots can do any of the experiments.
Very true. And one question I was asked is why is, like, for example, a scanning electron microscope, is something like that too sensitive to send on a lander?
Why did they not send an electron microscope?
Yeah, or why has one never been sent to
Well, initially it was far too heavy. They were considering sending an optical microscope on Viking, but that was canceled about midway through the process because it was deemed too hard to get a sample and put it on a slide.
Gotcha. All right. Let me see here once again. Want to make sure that we are covering all of the bases. As far as, let's move on, if you don't mind, to the danger of a pandemic, in terms of returning samples from Mars, which is indeed what we are planning to do with the Perseverance, or rather a follow-up mission to the Perseverance. Since microorganisms tend to evolve, dangerous ones, anyone, tend to evolve in conjunction with their hosts, do you feel that, what scenario do you see that a Martian a microorganism that's never experienced a mammal of any kind could possibly be dangerous? This is an objection I've encountered from a lot of people who comment on my site.
Jordan, hey Jordan,
Yes.
you're waking up badly all of a sudden. Can you stop this now and come back?
Yes. One moment. All right, getting back to the question. My a number of people who comment on my site have mentioned that dangerous microorganisms tend to evolve in conjunction with their hosts. That if there are no mammals on Mars or nothing similar to humans, then any microorganisms in that environment could not potentially be dangerous to humans. What scenario could you think of where there might be a dangerous microorganism?
Well, as I said before, Earth and Mars have been exchanging microorganisms.
Right.
So microorganisms that are dangerous to Earthlings or Earth life could have evolved on Mars and come over.
I understand. And also there has been a recent I'm not once again I'm trying to recall the exact circumstances, but also the levels of security and protocols behind the quarantining of these particular samples that may return in 10 years or something along those lines. There's been proposals to reduce the level of security. Can you confirm that?
You know, I think that's ridiculous. In 1965, NASA gave me a contract to study how to return samples from Mars. And my conclusion was, do not return them to Earth, return them to an orbiting laboratory or to a laboratory erected on the moon and study them there rather than take the risk of bringing them back, because there's certainly likely to be damage that would release the sample to Earth. And that happened with subsequent samples, including the return of the lunar astronauts who, spread stuff all over the place.
Would you say then that the Lunar Gateway, the proposed Lunar Gateway, would be a good solution for this?
Yeah, I think don't bring them back here. Take some experts to a lab up there and study them.
Excellent, excellent. All right. Let me go ahead and start moving to some of the questions that were asked. There are not a ton of them, just so you know. Bear with me for just one moment, and I am going to take them one by one. Let's see. Are there, if there were an expedition to discover life on another planet or moon other than Mars, and of course Mars is your specialty, but which moon would you or planet would you prefer? Where else in the solar system do you think life exists?
I really don't know. I really would hesitate to guess on that because the other environments are so different from Earth. Mars is the only one that we know of. There may be, way distant planets that resembles Earth pretty much. So I wouldn't be able to guess.
Okay. Bear with me for just one moment here. I'm moving to another question. All right. Bear with me for just a second here. All right. And I'm making sure that I am not repeating some of the same questions that that you had. Okay, yes, you answered the question about a microscope, and you've answered the question about other planets. Do you have a chart of the growth rate of the gas production over time? Is the rate consistent with life or a chemical reaction? That is, one would assume a chemical reaction to be steady while metabolizing would be exponential. Or did the life present only metabolize the nutrients and did not multiply and hence remain steady?
The thing that came closest to duplicating the Viking results in time and kinetics was hydrogen peroxide. However, hydrogen peroxide is not destroyed at the temperatures of the control of Viking, and particularly not just by sitting around if it's already present. In addition, in our Mariner 9 experiment, we were sensitive to hydrogen peroxide and found none to a very low limit that couldn't possibly cause the Viking results.
Thank you. The same individual also said if you had anything to mention about Ray and just a brief mention of your merchant marine history.
To do what?
Ray, your friend Ray in the merchant marine.
Oh, Ray Smith.
Yes.
And what do you want to know?
Just if there's anything for this particular subscriber was interested, if there was any comments that you might have in terms of you guys' relationship, any experiences that you guys had while you were in the merchant marine. I do believe that he may have had shared experiences.
We sailed 3 times on the same ship. And then Ray decided he wanted to go on a different ship. So we parted at that point. I sailed on, I think it was 6 ships, and I don't recall how many Ray sailed on. But yeah, I was in the North Atlantic, and we went up E-Boat Alley, were attacked many times, but we managed to get through. So we were the very lucky ones. And of course, our missions were pretty late in the war when the Nazi subs had been pretty well beaten. So what we were attacked by, but one sub attacked us, missed us. But what we were attacked by mostly were these E-Boat Alley boats that very fast, small craft. But as I say, we managed to get up to Liverpool.
Well, thank you. Thank you for that.
The worst thing was coming back one trip. We hit a terrific storm, and it was so bad that full steam ahead, we made only 75 miles in 3 days. We finally got back to New York and went in, and I went home for the weekend to Baltimore. Then I came back that Monday, and I went down to the dock, and all I saw was a mast sticking up. The boat had sunk. What happened was, in the storm, the stern gland had broken, but hadn't parted. But in the dock, when they began unloading, it shifted the weight, and the stern gland opened up, and the ship sank.
Wow. The kinds of experiences that people of my generation know very little about. I was born in 1969, so I never went through things like that. All I could do was study them. Okay. Once again, not a lot of questions left, so I'm not going to overload you with these. Okay. Yes, and I do believe that you've kind of answered this question, but I guess perhaps I'll go ahead and get you to make a solid statement on it. Would you be more excited if there was solid evidence of a second Genesis on Mars than the concept of transpermia?
Oh, of course, yes. They go together. I would be very excited to know that there was a second Genesis, and that this would just add to the conviction that microorganisms are traveling all over.
Yes, a very exciting concept to me as well. No doubt. No doubt. Okay, bear with me for just one moment. Okay, so you've kind of covered this, but let's go one more time. If you were to add an apparatus to an exobiology experiment for a new rover mission, what would you add?
Please repeat that.
If you were to add an apparatus for exobiology, some sort of new experiment, and I believe that you've briefly covered this, but if you don't mind to repeat it, for a new rover mission, what would you add?
Oh, yes. I have proposed a bunch of little rockets about as big as fountain pens, and each one would contain a different radioactive nutrient, and they would separate the left-handed from the right-handed amino acids. So I was proposing about a dozen of those, which would be very small. The whole thing would weigh only about a kilogram. That would be shot upwind after the spacecraft landed, so they wouldn't be contaminated by anything the spacecraft might have brought along. And then we would get the results radioed in from the little rocket to the spacecraft, from there to the orbiter, and from there to Earth, and we would learn which nutrients were metabolized and whether they were right-handed or left-handed.
Thank you. Thank you. Yeah, especially since it's only a few kilograms, it boggles my mind that these sorts of experiments have not been included on Opportunity, on Curiosity, Spirit. I mean, it's just astonishing to me that something so simple has not yet been included.
And also, I might point out, the experiment was accepted by Russia, and they had appointed me as prime investigator for the Russian 95 mission. And suddenly I got a letter from the head of the mission in Russia saying that the State Department had informed him that I could not transmit this technology to Russia. Now, that was ridiculous. Everybody knew how to use carbon-14. So this was to prevent the experiment going.
So, so NASA won't take the experiment, and they won't let you send it to Roscosmos either. Yeah, that's very difficult to comprehend. Like I say, I'm not the kind of guy who believes in conspiracy theories or anything like that. But wow, it just kind of flies in the face of reason. Okay, let's see here.
What I did then was to convert the MOX experiment, Mars Oxidant experiment, in which I was a team member. It was the experiment NASA was putting on the Russian mission, and I quietly converted it so it would detect life. But you recall the mission crashed.
Yes, I remember reading about that. Yes, it is unfortunate, very unfortunate indeed. The Russians have had very bad luck in their efforts to explore Mars. By the way, do you have any knowledge as to whether or not the Chinese lander has anything along these lines?
Which lander?
The Chinese lander that's due to.
They have not said, and it's my feeling that perhaps they included an experiment like the LR, and they're going to announce the detection of life.
So they'll be able to take credit for it first. Yeah, I've thought of that possibility myself. Actually, that's that would be something else, given the fact that your experiments were the ones that actually detected it decades ago, but they're the ones who are going to grab the credit. That would be a travesty. So, in any event, let's see here. I think we have moved the. One other question. There has been a suggestion made that with the salty brines that may exist on Mars, that something more complicated than single-celled organisms, something like sea sponges, might exist on Mars. What is your opinion on multicellular life or the possibility of that?
Well, it's very possible and likely that metazoans exist on Mars today. And there have been some excellent images of things that look like little mushrooms, and images of the same site taken several days apart show new ones popping up out of the ground and old ones growing. Hard to explain that also as inorganic material. And for me, the most startling thing was stromatolites were found, or things that look like stromatolites, which are piles of rock-like material made by microorganisms. And as a matter of fact, I was co-author with the young Fiardi of Siena University in Italy. He took images of stromatolites that resembled ones on Earth, and he compared them statistically. And lo and behold, he came up with a probability that their resemblance could only be attributed to chance alone by a probability of 0.0004. So that's very strong evidence for life.
Wow. Well, I mean, that being the case, Perseverance does have some extremely fine detailed cameras that can photograph things as small as a grain of salt. Do you think that there's a possibility that they might spot something that is of interest to them? And if so, do you think NASA might finally admit it?
I think they will avoid it. Curiosity has a very good camera also, and they would never accept my request to go to the green areas, which at first they ignored existed, and take close-up images. I sent an FOIA in, and the only answer I got back was NASA was downloading all the images it took. But it didn't say why it did not take images up close of the green stuff, which could reveal something. I'm not saying it would. I don't claim green means life, but it could be that the images could show biological features.
Wow. Well, I have to admit, I'm actually strangely more excited than I thought I was going to be by this interview, simply because of the fact that if indeed the Chinese are successful in landing there, and if indeed they take photographs of similar things, I do believe that they will not be so hesitant to announce the presence of life. Although, of course, this will be a tremendous disservice to you. But at the same time, at least I suppose you'll be vindicated if they do indeed say that that your discoveries were correct. I don't know. How do you feel about that? Do you think that you'll be vindicated if the Chinese were to make such an announcement?
I don't know. It would vindicate me at least, but I don't know if the other people will accept it. They might still say the Chinese were correct, but my experiment was incorrect.
Well, I I can't blame you for feeling that way, Doctor. Given the decades of frustration I'm sure that you have felt as a result of being told no as many times as you have. Yeah, yeah. I don't know what else to say except for the fact that there are many people in your camp, as you well know. And as my channel grows, I will continue to trumpet your findings and to anybody who will listen, because the evidence is indeed overwhelming, and the notion that we have already discovered life on other planets and did so decades ago is such a monstrous moment for science, and for us to deny it is just a travesty.
Yep, I agree. Well, I thank you very much
All
for
right.
your interest and that of your cohorts, and I hope something comes of all this.
Thank you so much, Doctor, for your time today. And once again, you have a pleasant day, and thank you very much for being on the show.
Thanks. Thanks a lot.
Take care,
Bye-bye.
Doctor. So, in conclusion, if you weren't convinced that there is life currently on Mars, I hope you're convinced now. Our interview revealed some things that I certainly wasn't expecting, especially when it came to multicellular life. And so, when man first steps foot on Mars, let's hope that whatever we encounter is not particularly dangerous. But until then, I urge all of you to stay angry about space.